So this is the switch that we're going to be using in the first part of our project, and we're going to take a look based on the previous video of how the ants run through the circuit. We're going to take a look at this board and see if we can figure out how all of this stuff works. So the first thing that we're going to be doing is let's take a look at the circuit itself. Now the first thing I want to point out is you'll notice down here in the background here that you have, it looks like little channels, and you can see it right in the, if you look hard, you can see it's hard to show this because it's very dim on the board, so trying to get the light in a picture to show the whole circuit is a little difficult. But where I'm drawing the red line is a circuit that goes to the different places. So what I'm doing right now is I'm drawing the connections for all the positive energy that is going to come through this particular circuit. So all of the different places that we're drawing lines, that's where all of this stuff is connected. All right, and so that is everywhere that the switch goes. And then the positive line, this is where the energy, this is what's connected to the battery. The positive line comes up here to this part right here, and I'm going to explain what all this stuff is here in just a second. And then we're going to jump over here. Let's get a green color here. And so we're going to say this is our negative line, and our negative line isn't connected to anything on this board except for this pin right here. So it's going to jump across that red line. They're not touching, so just be clear there. So that is the entire circuit for this particular board. We have our positive energy going up to this light emitting diode over here. So this is the diode right here, or the LED right here. So this little guy right here is an LED, and it comes through the LED and it goes through these resistors. So this is our resistor, and there's two resistors on here. Now the resistors look different depending on whether you're using surface mount resistors, which are what these are. They're really, really tiny. And if you are working on a larger thing where you're having to build it by hand, you typically won't use this type of a resistor because they're just so small and hard to work with. So, but what the resistor is doing is slowing down the ants as they run through our circuit, because this LED that's over here will actually blow out if the ants go through it too fast. So we want to make sure that, you know, this thing emits light and doesn't actually smoke and turn into the magic smoke. So if you look at this circuit closely though, you'll notice that at the present moment, what is happening is this switch right here, let me get a little bit better color here. So this switch right here, this pin on this switch and this pin on the switch are connected together. The switch has a little plunger that sits right here, and that plunger is out. There's nothing pushing it in, and therefore the switch itself is connected through these legs on this thing. But you'll notice that the ground that goes back to the negative part of our battery is not connected to any of the red stuff. It's only connected to itself and to that center pin. And so what happens as a result is the ants can't go through the circuit. The light's not going to come on, nothing's going to happen because the ants have nowhere to go. And so they're just going to sit there, they're going to get all excited because they're going to get to go on a trip, and then there's no connection, so we're just going to have to sit here. And so they don't move, they just sit where they're at. However, as soon as I push this switch down, it pushes this plunger down, and as soon as that happens, the connection changes to being between these two legs instead of the other two legs. Now look at what happened as soon as you push that switch down. The entire circuit completes, because now I have a way for the energy to go through this leg, up through this leg, the ants can come down through here, and now they can go out of the circuit and back to the battery by jumping down through this negative wire and going back out to the battery. So now what ends up happening is this switch line right here becomes hot. It becomes, this particular circuit, it is known as a digital circuit. And what that means is that it is either a 0, so we either have a 0, which means no current, no electricity, and it means that it's open. So this is open. So think of 0 as the O in the open. Or it's going to be a 1 in a digital. Digital can only be a 0 or 1. And so your entire computer that you use every day, all it knows are zeros and ones. And so at this point, it is closed and it has electricity flowing through it. So this leg right here will not have any energy flowing through it. None of the ants are going to go through that leg. The ants are going to come up through here, but they got nowhere to go until you close that circuit and allow them to travel down this leg and out this switch, this state line. So as soon as the switch is pushed in, the state line becomes active, and now the ants can flow all the way through this circuit, light up the diode. So this LED is going to light up, and then the ants are going to go right out that state line, and that is what the computer is looking at, is the whether or not it has energy flowing out of that state line. And so this is a very simple component. It's a switch that we are going to be using to see if we can count how many times the wheel on the bicycle turns around to do something. So every time the wheel turns around, we're going to have something that's going to bump this switch, and it's going to activate the circuit, and then our program that we're going to write is going to count how many times that circuit has been activated, and it'll know how far that wheel moves, and then figure out how far you've moved and how fast you're currently going based on how many times that thing's being tripped. Now, there's a lot of other circuits that we have available that we can also, or that we're also going to try to use. But all of them are exactly the same circuit. It's just this switch right here is different based on what, some of them are magnetic, some of them are pressure, some of them are light. So it just depends on how you're going to activate that switch. But the mechanics behind all of it is that the ants have to have a way to come in, and they have to have a way to go back to that battery. And as soon as that happens, this circuit becomes live and starts to do some work for you.